Question number 12. Question number 12 says three 3-ohm resistors are connected in parallel. What is the equivalent resistance? So we have three 3-ohm resistors connected in parallel. What is the equivalent resistance? So this is under current electricity, and you know a couple of things that you need to know under current electricity. So what we're given that 3 ohms. There are 3 of them. 3 ohm resistors connected in what? In parallel. So in parallel, the equivalent resistance is not known. Okay, so let me try to draw it. We were not told the arrangement, but a parallel arrangement is the one in which you have a connection to the same terminal of the elements in question. So let's say you have resistors, for instance, now. So all of them are connected. They have the connection to them to the same terminal of each of those resistors. So you have this, you have that, like this. It could be arranged like this, or it could be this other way around. So you have it like this. So you have a sort of connection like this. So this is a terminal, 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 this is a terminal. So you have, this is R. So let's say this is R1, and this one is R2, and this is R3. Okay, so a point to note on that series connection, parallel connection is note for parallel connection. For parallel connection under current electricity, please. For parallel connection under current electricity, the equivalent current, or the total current, in the circuit is equals to the summation of all the currents across each resistor, each of the resistors. So let's say the current across this one is I1, and this one is I2, and this one is I3. Okay, so what we are saying is the total resistors, the total current I total is equals to I1 plus I2 plus I3. Now I just want to do a sort of derivation and give you some sort of background under parallel connection in current electricity. So this is really may not be that necessary when you're writing Jamb. I always say that a lot. So it's just to give you the understanding. So point on, we're just supposed to just have the formula and just solve what we need to solve. But I want to give you how the formula that we're going to be using is actually derived. You understand? So just in case you're using the same material for another exam, so you're able to have that understanding, or even writing your Jamb too, you need to have the understanding, just cramming. Okay, so we have high total equals to high 1 plus high 2 plus what plus high 3. Okay, so the second point to note here is the voltage. The voltage across each resistors are what? Are the same. Are the same, and it is equals to the equivalent is equals to the equivalent. Let me move that down to the equivalent voltage of the what? Of the circuit. So what we are saying is, if voltage that passes through this in the old circuit is V total, you know, so you have the one that comes in here, you have it to be equals to V1, this one to be V2, and this one to be V3. Then let equally have high total that is coming in here. You understand? So what we're saying here is B total is equals to V1 and is equals to V2 and is equals to what? V3 and equals to Vn, depending on the number of resistors that you have. Now, from these two formula, this is what we have. From these two items I have listed down, so we can say that we have your I total is equals to I1 plus I2 plus I3, like that. So let's call this equation 1, and then recall your Ohm's law in current electricity that says that recall Ohm's law. Ohm's law says that V equals to what? IR. Okay, so from here now, it implies that I equals to what? V over R. Okay, so if I call this one equation 2, now if I put 2 in 1, in equation 1, then I will have, instead of I total, I will have V over R. How this is total is equals to I1 V over R, or this is 1, plus I2 V over R, or this is 2, plus I3, this is V over R, or this is what? 3. So this gives me V total over R total, and this is equals to V1 over R1 plus V2 over R2 plus V3 over R3. Now, but from our observation, we said V total equals to V1 and is equals to V2 and is equals to V3. And if we denote all of this by V, since they're all the same, we just use 1 for them. So we say but Vt is equals to V1 and is equals to V2 and is equals to V3. And let's say this is equals to V. Then we would have this to be equals to V over R total to be equals to V over R1 plus V over R2 plus V over R3. So this V is common here, so I take it out, so I have 1 over R1 plus 1 over R2 plus 1 over what? R3. So this V would effectively cancel this V. So I will now have this to be equals to 1 over R total to be equals to 1 over R1 plus 1 over R2 plus 1 over what? R3. So this is what we have as the general formula for calculating the equivalent resistors or resistance in a parallel connection. So we have 1 over the total resistance or the equivalent resistance or the overall resistance is equals to the reciprocal, the summation of the reciprocals of all the resistance in the circuit. So you have, now in this case we're told that each of those resistance is having 3 ohms resistance. So we have 1 over R total to be equals to 1 over 3 plus 1 over 3 plus 1 over 3. So the simple mathematics, this is 3 and 3 1 plus 3 and 3 1 plus 3 and 3 1. This is 3 over 3. So it implies that 1 over r3, 1 over r total is equals to 3 over 3. So you have 1 over r total to be equals to 1. If you cross multiply, you have your r total to be equals to 1 ohms. Okay, so you have your r total to be equals to 1 ohms. That's question number 12. Now moving on to question number 13. So question number 13 now says, which of the following instruments helps to maintain the correct humidity and temperature of a building? Which of the following instrument helps to maintain the correct humidity and temperature of a building? So option A says compressor. So let's look at compressor. So compressor is simply an equipment that is used to increase pressure for fluids by reducing their volume. So when you have a container that is having fluids, be it liquid or gas, and you want a pressure in that container, so all you simply do is just reduce the volume of that container. When you do that, then there will be an increased pressure. Don't forget your pressure law that says your volumes and your pressures are inversely related, and it's a very simple a common sense scenario that you can have in your house or anywhere you're here, in your car or something like that. When you have more people in a car, for instance, this generates pressure because there's no space, there's no radius of gyrations. You can't even relax well and all of that because of lack of space. So when there is lack of space, which is called volume, there will be an increased pressure. You understand? So this can be advantageous in some cases. For instance, compressor, for instance, we use it for pumping water. So if you want to pump water, you stuff like that, you use a compressor, and this is going to increase pressure so that you can have a lot of force. Then the flow of the water would be increased. And then we use it in fridge too and some other equipments like that. So you have compressors used here and there. But essentially, what we're concerned about here is compressor is used to increase pressure in a fluid by simply reducing the volume of that compartment. So that's about that. So it's a mechanical device. Compressor is a mechanical device. Use so that increases the pressure of a fluid by simply reducing its volume. So that's about compressor. So compressor is never used to maintain the correct humidity and temperature of a building. Then your second option here says a refrigerator. So refrigerator is equally that thermally insulated materials that has an heat pump and that transfers it from the inside of the fridge to its environment. By virtue of this, the temperature within the fridge is lower, cooled below the ambient temperature of the room. So essentially that's what a fridge is. So but when you look at inside your fridge, the humidity is not there's no moisture. When you go inside your fridge, you feel moisture, so you feel a lot of liquids. Even when you have a dry fridge, by the time you start working, when you get in there, you see because this is part of its operation. Are you getting it? So it's very close to AC. Are you getting it? But it's just some sort of differences. So here, yeah, temperature right, but humidity no. So we have a fridge is a popular household device. So that consists of a thermally insulated material, insulated compartment with what? Heat pump that transfers heat from the inside or from within the fridge or inside of the fridge to its environment. Okay, to its environment. By doing this, the temperature within the fridge is cooled below the ambient temperature of the environment. Okay, though so this is what your fridge is, so that's not new. Hair blower, what do we use air blower for? Air blower, that's another option. That's option C, says hair blower. Hair blower is just that equipment that you use to release air. So you use it to release air, maybe cold or hot air, we don't care. We use hair blower to do what? To release hair. So you see engineers repairing systems, the computer, use it to, you know, blow off some things in your computer. They just open your system off, and then, you know, maybe somewhere is dusty and you need to, you know, clean it up. You blow it, and then so even the cleaners, the industrial cleaners, equally use blowers and all of those things. So you use blowers here and there to essentially what you're using them to do is what? Release hair maybe at very high pressure, sometimes, most of the times very high pressure. Okay, so that is that's about that. So hair blower used in what? In releasing the what? The hair. That's what we use hair blower for. And then the last option there says is the hair conditioner. Hair conditioner. So air conditioner is that mechanical equipment as well that is used to you know, remove temperature and moisture from an environment. So hair conditioner is equally a mechanical instrument used in removing heat and moisture from an environment. Okay, so that is what an air conditioner is. So most of the times you have it being a closed environment, so you could have it in your car, you can have it in your house and wherever. So the heat has to do with the temperature, and the moisture has to do with what? The humidity. Okay, so that's why the suitable answer for this question is hair conditioner. So most of the times you do this to improve your comfort. Okay, you do that to improve comfort.